All right, welcome back. What we're going to do today is we're going to find the derivative of arc sine, the inverse sine function, and we're going to do something a little bit tricky because we don't have a rule for the derivative yet. So what we're going to do is we're going to just take the sine of both sides. So step one, we're just going to say, well, if y is equal to arc sine of x, then sine of y equals to x. And now we can use implicit differentiation. I know that the derivative of sine is cosine, and the chain rule says I have to multiply that by the derivative of whatever y is. The derivative of x is equal to 1, which means that the derivative of arc sine is equal to 1 over cosine of y. Well, that's not super helpful because that's 1 over the cosine of arc sine of x. So why would I want to do that? Well, I wouldn't. But what I do know is I do know that cosine squared plus sine squared is equal to 1. And I know that sine is equal to x. So cosine squared y plus x squared is equal to 1. Sine y is equal to x. Let me clarify that. Which means that cosine of y is equal to the square root of 1 minus x squared. Ha! Which means that the derivative with respect to x of arc sine of x is equal to 1 over the square root of 1 minus x squared. So very quickly, let's extend that to the derivative with respect to x of arc sine of some function of xu. It's going to be equal to 1 over the square root of 1 minus u squared times the derivative of u with respect to x using the chain rule. And we're going to highlight both those equations, and then we'll do a quick example, and then we'll be done. This is going to be a quick video. So let's take a look at our example. Our example today is find the derivative with respect to x of arc sine of x squared. Well, this is, we'll let u equal x squared. So this is 1 over the square root of 1 minus u squared times the derivative of u. Be careful, this is where people mess up. I've got to plug that x squared back into this equation. This becomes 1 over the square root of 1 minus x squared squared, which is x to the 4th times 2x. And I'm done. So if you're in my class, go ahead and do exercise 3. Remember, we're in section 4.3. And we'll come back with the derivative of the inverse tangent function. Thanks for watching.